Okay, so from that same junction at the starter relay, now the current also goes through our starter generator. So you see in this point how it goes from C plus to B plus and down to E to ground. Does that make sense? So it's going through the starter winding, through the armature to ground. So you have battery power, which is electrical energy, that's driving the starter motor. That's all a starter is a motor.
So that right there, those are the intervals. That's the interpole. No.
The interpoles are for the generator side of it. It is going through that coil because it has to, but I'm not sure how that interacts magnetically. Don't worry about it.
Okay.
Yeah, that could get very confusing. So what we need to focus on right now is that it's going through the starter winding, through the armature to ground. Any other questions? And that is using the starter side of the starter generator. Now, as soon as you let go of the switch, it's spring-loaded to go to run. And I think the Skyhawks are like that. Is the Citabria like that? After you start, it's spring-loaded. I don't know how the...
Only 2 mag switches and a starter button.
Oh, the button. Okay. Yep. Never mind then.
Alright.
So when the switch is on run, that top solenoid is going to come open. So we don't have current going to the igniters, and then the current is not going through the starter portion of the starter generator. And so that part of the circuit is not being used at that point. Now current is coming out of the generator and charging the bus, right? Because it goes backwards, the bus into the battery. And it also goes, so it goes to the left and the right. It kind of splits off right there. Okay? So now the current, instead of going into the starter generator, is being produced by the starter generator. Current also comes through the switch, through the field relay, which will close that solenoid. That will allow current to, that was magic in the box, to go through the solenoid, through the parallel relay, or the parallel coil to ground, and that will control our lines of flux that are going across the armature. The voltage regulator is determining how much current is in the field. So if it raises the current in the field, the generator output will increase. Lowers the current in the field, generator output will decrease.
So, when we started, the battery produces the current, sends it through the generator, and that's what gets us moving. Starter.
Yes.
And then, that's what gets it moving. It sends the current to the exciter, igniter.
Yes.
Something like that. And then once that's off, it's just kind of like self-sustaining.
Well, it's in run mode, so it's acting as a normal generator. As the engine turns it,
Okay.
now it's being driven and the lines of flux are being cut and it's creating energy rather than accepting energy.
Okay. So, and then it in return charges the battery and goes to control itself.
Yep.
With the
Yep.
generator.
Exactly.
Okay.
Very good. So let's look at the circuit breakers because you will need to know the order of these on the test for Friday. Obviously, maybe not obviously, but the highest current circuit breaker is going to be the starter, the one for the starter, because it takes a lot of torque to start that engine, and a lot of torque takes a lot of current. So there is a ton of current going through that starter circuit breaker. So that's going to be the highest rated circuit breaker of the 4. After the starter, then we have the generator, because all the current being produced by the generator is coming back to charge the battery and the bus. So that's going to be a fairly high rating on your circuit breaker. The other two are even. It wouldn't matter which way you numbered them. So you could say 3 and 4. They're basically just running solenoids, so that's not going to be very much current at all. They're just, they're switches. They're just powering the solenoid. Does that make sense? Okay. Any other questions? That's the end of the slide for the schematic. And then we'll go through and make sure you have all the blanks.